Welcome to HIVE, a community empowerment project revolutionizing housing through an innovative platform-based approach that revolutionizes design, construction, and occupancy processes for greater equity and innovation. Addressing population growth and resource constraints, HIVE champions inclusive design, prefabrication, and community engagement. This establishes a distinct architectural model centered on the creation of holistic living environments. HIVE embraces the collaboration between developers setting typologies and residents actively shaping their living spaces, resulting in a symbiotic paradigm with a sense of shared ownership. The HIVE scheme, at the convergence of innovation, education, and collaboration, engages these core audiences, providing them with a tailored pathway that blends their aspirations with its main essence. It embraces interventions at various scales, from micro-digital fabrication to macro data sharing, inspired by the connected globally and managed locally ethos of the Fab Lab model. We now dive into the computational aggregation of HIVE from the perspective of developers' experiences within the platform. Structured in 3 core sections centered on typologies development, 4 primary hexagonal cluster types are designed with distinct circulation formations. The cluster designs were generated by subdividing hexagons into smaller units through a grid overlay, leading to 3 main types. Utilizing the WASP extension, connection sockets were meticulously defined, laying the groundwork for adjacency rules, written to enable the intertwining of the circulation formations. This methodology follows the wave function collapse model, where one option's presence affects nearby clusters' occurrence probabilities. The exploration extended to site-specific constraints to accommodate numerous flat or steep terrains. Additional structural support rules enabled vertical and horizontal aggregations, with road conditions integrated to enhance the system's adaptability. Diving deeper into the cluster combinations resulted in the analysis of numerous spatial configurations, varying cluster types, within set boundaries and fixed clusters' occurrence probability, informed the aggregation possibilities. We developed an algorithm based on iterative logic, which facilitates the regulation of the density. The replacement process factors environmental considerations and current site conditions, which assess each unit's value in relation to its context. 3 key factors influence this assessment: privacy, view quality, and view boundary. When computing the aggregation on the selected site, adjusting the density directly impacts the resulting typologies by shifting the balance between built and unbuilt green spaces. Employing an algorithmic approach that assigns scores to each of these units, the system guarantees optimal placement of resulting features, be it green spaces or public areas, where their needs are fulfilled. The system effectively computes which units should be substituted by green or social spaces within a specified range, aligning with developers' aspirations. We gain valuable insight into the developer's first-hand encounter within the platform that integrates this computational framework. The process they follow begins in the pre-aggregation phase, characterized by a variety of actions: registration, site selection, and inputting initial building parameters. After selecting the site in the pre-aggregation, the developers are able to select the core type, place it, then input their preferences when it comes to the number of units, their expansions, and circulation node connections. This automatically adjusts the density percentage of each within the resulting aggregation. After that, we proceed to the post-aggregation section where the developer inputs the density input. And when each unit is analyzed and the replaceable units are highlighted, they are automatically replaced by the open ones, which functions and locations depends on the specific site factors, contextualizing the typology within its respective site. As we proceed, the system optimizes the structure where needed, resulting with a typology customized by the developer. Moving forward, we delve into the architectural design, a pivotal aspect that holds significant relevance within the resident's experience. Structured into 4 distinct segments, the resident's UI design orchestrates a comprehensive journey, enabling them to curate their living spaces according to their preferences and needs. The fundamental modules were categorized as dry and wet units, amalgamating to shape a studio apartment. This is done with the intention to simplify the building services by clubbing functions that require plumbing and drain pipes in spaces such as toilets and the kitchen together. Embracing the principle of design flexibility in response to the demand for space, the design activates the separation of the interior units, evolving alongside users' changing needs. This is achieved through the integration of a timber panel, rotatable and movable pop-up partition. As a result, the project encompasses flexibility, efficient space utilization, and extensive customization within its design paradigm. The facade design embodies key principles, catering to quick disassembly, adaptability, and customization, while adapting to the slab structure's form. It comprises a timber skin section and concrete finished framing bands that visually unify floor plates and conceal building surfaces. These skin elements are subdivided into smaller components for streamlined fabrication. Notably, an interplay exists between interior spaces and facade kits. Transparent openings illuminate living and public areas, while private and obstructed spaces incorporate timber grating and solid wood panels for privacy and safety. Ultimately, the facade aligns with interior layouts akin to a wave-function collapse model, with furniture arrangements dictating the cat's occurrence. The comprehensive dwelling unit design stems from the harmonious integration of interior and exterior unit kits, which are tailored according to their respective functions. The kit's relevance is underscored by its versatility and adaptability. The external units are broadly classified based on their functions into green spaces, social spaces, and productive spaces, and inclusions of kits that are combinations of the functions. The kits that fall under green spaces include small planters, turf. Within the residents' UI experience, it becomes evident how they adeptly navigate the co-design process and actualize their requirements. Organized in a threefold structure reminiscent of the developer's user interface, the UI features a streamlined dashboard, which offers an overview of the main sections, which can be accessed through a single click, an interactive display window, mirroring real-time alterations, and an action set section positioned to the right of the screen, enabling them to input all their preferences and make their selection. The immersive experience crafted within the HIVE Hub is a captivating journey that invites users to submerge themselves within the project's intricacies. Similar to the platforms which prioritize user immersion, the design ensures that the residents or players remain engaged, fostering a sense of familiarity and ease. The synergy between the visual appeal and the intended utility reinforces the effectiveness of the UI design. This balance results in an intuitive overall user's experience. It extends beyond individual units, encouraging users to delve into the broader neighborhood to cultivate a comprehensive understanding of their neighbors, community dynamics, and the pulse of events within the residential development. By seamlessly blending information and engagement, this immersive experience empowers users with multifaceted insights. The ability to interact with neighbors virtually fosters a sense of community, transcending geographical boundaries. Users can initiate conversations, foster connections, and gain valuable perspectives, all within the digital realm, mirroring reality. This experience ingeniously melds information sharing with a gamified atmosphere. As users freely navigate through virtual environments, they unlock a unique blend of education and engagement. In the post-units design section, The focal point is the fabrication aspect that shapes the foundation of HIVE. Topology optimization has been extensively explored to reduce weight while preserving structural integrity. The column construction approach involves a two-step process to hardware for robust connections. The facade corner details the structural layers, offering user choices for flooring and interior finishes. The process of assembling an individual dwelling unit includes integrating the optimized slab with columns and incorporating essential hardware. MEP lines and facade timber skins are then integrated, followed by the installation of joinery and louvers. Showcasing fabrication and structural intricacies, the HIVE Hub allows users to meticulously explore their dwelling unit within the virtual experience. From the optimized slab specifications to precise concrete joinery and fabrication updates, it provides an in-depth understanding of the construction's foundation and framework. This level of details empowers residents, developers, and even building management teams to scrutinize every facet of their living and working spaces. Ultimately, HIVE cultivates a unified global community of individuals and entities involved in housing, construction, and manufacturing. Serving as a centralized platform, it facilitates connections and engagement among users across diverse projects in cities worldwide, transcending mere visual representation. This is how the virtual experience drives innovation in the housing process, shaping the essence of HIVE.